Hey, I'm Keely Raven from KeelyRaven.com. Are you just getting started in trigonometry class and wondering what the heck is going on? Or maybe you just need a review of the basics. In any case, in this video, I'll give an introduction to trig from the ground up. So we start from scratch. You'll learn how to identify and label a right triangle, as well as how to solve it with SOHCAHTOA. If you're new here, welcome. Go ahead and subscribe down below, click that button, and also click the bell so that you get notified whenever I release a new video. That way, you'll be able to get that competitive edge in your class right away. This video is actually an excerpt from my membership site that I created for students who wanted to do better in math class. Maybe they're already at the top of the class and want some more practice problems so they can do better. Maybe they just need a better explanation than their teacher gave, or perhaps they really have no clue and just need to get started again with a new understanding. So this site is for them. I've taken the video from there to give it to you, and hopefully it will help you in your trigonometry adventures. Anyway, if you're looking to learn more about trig, stay tuned. Welcome to an introduction to trigonometry, the math subject that is so cool. I think it's the only one to have its own nickname. So we are talking right triangle trig and SOHCAHTOA. See, trig, the nickname. Anyway, you may or may not know what all that means right now, but by the end of our talk on trigonometry, I promise you'll totally get it. So when we talk about right triangle trig and SOHCAHTOA, we first need to look at the right triangle. If you're going to use SOHCAHTOA, you must be working with a right triangle. A right triangle is a triangle with one 90-degree angle and two acute angles. So you can be sure that you're working with a right triangle when you see a square in the corner like this. This box indicates that you have a right triangle, and this box is located where the 90-degree angle is. Then you have your other two acute angles, one of which may or may not have any sort of indicators in it, and the other one here, which we're calling theta. Why do we call it theta? I don't know. I think math teachers just think it's cool to use Greek letters in math. Whatever, it's theta. Think of it like x in regular algebra. This is an unknown angle. The other things you want to know are the parts of the right triangle. So, first we have the hypotenuse. In every right triangle there is a hypotenuse, and it is the side that is opposite the right angle. Always. The other two sides are named in reference to our angle theta. The side the furthest from theta, the side opposite theta, is called the opposite side. And the other side, the one next to theta, is called the adjacent side. Adjacent is a word that means next to. And you may have noticed this, but the opposite and adjacent sides will really depend on where theta is. If theta were here at the top, these would be named differently. Just something to take note of. Anyway, that's what you need to know about the parts of the right triangle. Next, we're going to talk about SOHCAHTOA. All right, SOHCAHTOA. This is really an acronym. It stands for sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. That still may mean nothing to you, and it's okay. I just want to give you an introduction right now. So with SOHCAHTOA, it really stands for these trigonometric functions. Those functions are sine, cosine, and tangent. Those are the three that we will talk about right now. And it's not so important that you know that they're functions, but really you want to understand that they are ratios. So sine is when you want to find out the sine of an angle theta, then you look at the length of the side opposite theta and the length of the hypotenuse, and you divide them. Sine theta equals opposite over hypotenuse. That is the SO in SOHCAHTOA. When you want to find the cosine of an angle, then you look at the length of the side adjacent to theta and divide that by the hypotenuse. Cosine theta equals adjacent over hypotenuse. That is the CA of SOHCAHTOA. And when you want to find the tangent of an angle theta, you look at the side opposite theta and divide that by the length of the side adjacent to theta. Tangent theta equals opposite over adjacent. That is the TOA part of SOHCAHTOA. So you might have also noticed that I didn't write out sine and cosine and tangent. Instead, you see sin, cos, and tan. And really, these are red, sine, cos, tan. But, you know, my math teachers always told me that mathematicians are among the laziest people on the face of the earth, and I agree. We like to do things in the least amount of steps, write the shortest thing possible. So why write out all the letters? We come up with abbreviations. And actually, these are the abbreviations. These you will see on your calculator as well. They're written out sine, cos, tan. So that's what you need to know about SOHCAHTOA to start. Let's look at some examples. This is a basic SOHCAHTOA problem. And when you're looking to do something like evaluate the triangle for sine theta, cosine theta, and tangent theta, I recommend actually writing the acronym SOHCAHTOA at the top of your paper so that it's always there for you to refer to. Now, here's our angle theta. And a good first step, well, after labeling your paper with SOHCAHTOA, is to identify the sides. So here's our right angle, and directly across from the right angle is our hypotenuse. So it's a good idea to label it. I'll just put hype. And then all the way across from theta, we have our opposite side, the side opposite theta. I'll call it op. And then next to theta, our remaining side is our adjacent side. I'll just write edge. So when you want to find sine theta, we look at SOHCAHTOA, and sine is opposite over hypotenuse. So if we write this as a reminder, then we can look. The opposite side is 4. So we have 4. And the hypotenuse is 5. So we have 5. The sine theta equals 4/5. For cosine theta, we look at SOHCAHTOA. CAH. Cosine is adjacent over hypotenuse. So you can make a little note here. Adjacent over hypotenuse. That is some really great handwriting. And we look at our adjacent side, that is 3, over our hypotenuse, which is 5. Then the cosine of theta is 3/5. And now we need to find tangent of theta. So we can refer to SOHCAHTOA, TOA. Tangent is opposite over adjacent. So nice to write with a mouse. Opposite over adjacent. And in that case, when we look at our triangle, the opposite side is 4, and the adjacent side is 3. So the tangent of theta is 4/3. For our second example, we're going to look at the same triangle, but this time theta is the other acute angle. Now watch what happens. You still would have SOHCAHTOA at the top of your paper, and when you want to find sine theta, you still think, oh, I should label my sides. So 5 is still the hypotenuse because it is still the angle opposite the right, or sorry, it is still the side opposite the right angle. But now theta is up here, so the side opposite theta is way down here where the 3 is. So we'll label that op for opposite. And then the side adjacent to theta is right here. It's where the 4 is. And we'll label that ADJ for adjacent. Now, the sine of theta, it's still opposite over hypotenuse, but this time the opposite side is 3. So we still have opposite over hype, but op is 3 this time. Hypotenuse is still 5. When we want to find cosine theta, it's still adjacent over hypotenuse. Just now that theta is here, the side adjacent to theta has a length of 4. So look at adjacent over hypotenuse. We have 4, and we know the hypotenuse is still 5. And when we want to find tangent theta, it's still opposite over adjacent, and now 3 is opposite and 4 is adjacent. So the tangent of theta is 3/4. Notice that whenever we write the answers for sine theta, cosine theta, and tangent theta, we're writing fractions. And you may have noticed at this point that the fractions that were written for sine theta and cosine theta are less than 1. But for tangent theta, it can be anything. In the previous example, the tangent of theta was this flipped over because theta just changed places. So opposite and adjacent changed places. So it was 4/3. Tangent can be any number. Cosine and sine are fractions less than 1. And if you think about our previous example, sine and cosine have switched places because theta switched places. Let's look at another example. In this case, our triangle has a different orientation, and we only have 2 out of the 3 sides. Two of the 3 sides have their lengths indicated. So there's a couple ways to know the third length here. One is to use the Pythagorean Theorem, which you may remember as a squared plus b squared equals c squared. And in this case, you want to decide, well, you know that the hypotenuse is always c, and then the other 2 sides are a and b. And it doesn't matter which is a and which is b. In this case, we're going to find b. So a squared would be 5 squared plus b squared, we don't know b, equals 13 squared. And then as you do the math, you get 25 plus b squared equals 169. And if we follow through with our algebra rules, we subtract 25 from both sides, and we get b squared equals 144. And we take the square root of each side, and we get b equals 12. Okay? So now we know that this side is 12. Then we want to think, let's label our sides. We have SOHCAHTOA written at the top of our paper. And now we want to label our sides opposite, adjacent, and hypotenuse. Well, we have the side that's across from the right angle. This is our hypotenuse. And then if we look at theta, that's here, the side opposite theta is 5. And the side adjacent to theta is 12. A, D, J. Now I mentioned before there are a couple of ways to find the missing side length. One was to actually do the Pythagorean theorem. The other is to know that there is a such thing as a 5, 12, 13 triangle, and that's a right triangle. If the hypotenuse is 13 and one of the sides is 5, the other side is 12. That's one of those sort of special triangles. The one that we worked with before was a 3, 4, 5. That's another special triangle. So to evaluate for sine theta, we know sine is opposite over hypotenuse. We find 5 is the opposite, or the length of the opposite side, and the hypotenuse is 13. So the sine of theta is 5/13. Cosine is adjacent over hypotenuse. The length of the adjacent side is 12. And the length of the hypotenuse is 13. So the cosine is 12/13. And for tangent, we use opposite over adjacent. The opposite side is 5. The adjacent side is 12. So the tangent is 5/12. And that's how we do that example. Here's one more example with a triangle in a different orientation. And I do that because sometimes that's the easiest way to trip up a student, is to change the way the triangle looks. But you're just looking to make sure that there's a right angle. And there is, so it's still a right triangle. We're still using SOHCAHTOA, and we're still able to evaluate for sine, cosine, and tangent of theta. This triangle also has a missing side length. So we can do the same thing, use the Pythagorean theorem. If you label your sides, you know the hypotenuse is across from the right angle. That's side C, and I'll just go ahead and write hype because we're going to use that when we use SOHCAHTOA. And then we can just call this one A. And here's theta, so A is opposite theta. And I'll just call this side B, and we can see that is next to theta. This is adjacent. Okay, so if we're going to use the Pythagorean theorem, then we know A squared plus B squared equals C squared. And A squared, we don't know A, so we'll just write A squared plus 24 squared equals 25 squared. And A squared plus 576 equals 625. Then we subtract using our algebra rules. Subtract 576 from both sides minus 576. We have A squared equals 49. And if we take the square root of each side, we get A equals 7. So you could either use the Pythagorean theorem and solve that, or know that a 7, 24, 25 triangle is a special right triangle, and if the hypotenuse is 25 and one side is 24, the other side is 7. And now for the trig functions. Sine of theta is opposite over hypotenuse. Opposite is 7. Hypotenuse is 25. So our sine of theta is 7/25. Cosine theta is adjacent over hypotenuse. The adjacent side is 24. And the hypotenuse is 25. So our cosine of theta is 24/25. And tangent theta is opposite over adjacent. So opposite is 7. And adjacent is 24. So the tangent of theta is 7/24. That's all for the introduction to trig and the basic SOHCAHTOA problems. And next we'll get into some more difficult problems, and you'll be very grateful that you have SOHCAHTOA to help you solve them. I hope this video was helpful to you. If it was, please go ahead and give it a like. And while you're here, check the links in the description for some more free, helpful resources. Bye for now. See you on the next video.